I'm Anil Kumar. Welcome to my series on functions. In this video, our focus will be how to evaluate value of a function. Now for that, we have taken 10 questions. Here's the very first one with 4 parts. Question number 2, we'll work with 2 functions. It's like composition of functions and then evaluating them. In question number 3, we have functions in the form of set and the form of equation, and we'll again work with the composition of functions. Question number 4 is to understand domain and range and the mapping diagram for the functions. Question number 5 is a word problem. We'll see how to form equations, rather the functions, and then evaluate or work with those functions. Question number 6 is a very interesting question which has been seen in many competitive exams, so that is of prime importance to us, especially if you want to prepare for exams like SAT, IIT, and so many other institutes. Question number 7 is again a very interesting question where we are trying to generate a series with the help of given function. Question number 9 is to understand reciprocal function and also solve the question as to when will the function and its reciprocal have the same value. Question number 10, we'll see if we are given table of values for the functions, in that case how to evaluate the value of function and composition of such functions. So I hope that will give you a very good knowledge about the topic, which is evaluate the value of functions. Now let's begin with question number 1. You can always go back and forth, solve some questions yourself, and then look into my suggestions. In question number 1, we need to evaluate the value of the function at x equals to 2. Calculator normally is not allowed, but if you want, you can always use it. I've taken simple values so that you can evaluate without the help of calculator. So when we say evaluate the value of the function at given x value, you have to only substitute the value in and find what the output f of x is. So in the very first one, at x equals to 2, I can write this as f of 2. That means value of function when x equals to 2 is 5 minus, we'll replace x with 2, so we get 2 over 2, and that clearly is 5 minus 1, which is 4. So the value of the function is 4, right? So you can write this answer as something like this. F of 2 is equal to 4. Is that clear to you? Perfect. So that is how you should do it. Now you can evaluate rest of these questions. This is a rational function, so we can again substitute the value 2. Since we're trying to find the value of the function at x equals to 2, we get this as equals to 2 over, replace every x with 2, right? Minus 3 over 2, correct? So we get 2 over 2 minus 6 is minus 4 minus 3 over 2. You could simplify this. This is minus half minus 3 over 2, correct? Now minus half minus 3 over 2 is minus 4 over 2, which clearly is minus 2, right? So in this case, f of 2 is minus 2. The next one here is h of x equals to all this. We'll again substitute the value of x as 2. So when I'm saying x equals to 2, it means simply substitute the value of x as 2 and evaluate, correct? You may need a calculator at times, so you may use for some of the questions. So replace x with 2, right? And then evaluate. So what we get here is minus 5 times 2 square is 4. 20 times 2 is 40 plus 1. Okay, so we get here minus 20 plus 40 plus 1, correct? So minus 20 plus 40 is 20 and 1 is 21. So we get h of 2 as equal to 21, clear? The last one here, g of x is square root of something. We want to find what g of 2 is, correct? So g of 2 will be equal to square root of 11 minus 2 plus 1, which is square root of 9 plus 1, which is 3 plus 1, which is 4. So we can write this as g of 2 equals to 4. Is that clear? So I hope this question is absolutely clear. Let's move on and take up the next question. If f of x equals to 2x minus 3 and g of x is x squared minus 1, find each value. F of minus 3. So just as we did in question number 1, substitute minus 3 for x, right? So f of minus 3 is 2 times minus 3 minus 3, correct? Which is minus 6 minus 3, which is minus 9. Next one is 2 times f of minus 1. That means 2 times. Keep 2 as such. F of minus 1 means substitute minus 1 here, right? So let me use a bracket now. So we are using minus 1 for x. So we get 2 times minus 1 minus 3, right? Plus, now here we have within bracket square and inside we have g of 2. So this 2 will be substituted in the function g of x. So what you get here is 2 square minus 1. So that is g of 2, right? That is g of 2. And then we have minus 1 and we have to square it. Perfect. Now we get 2 minus 2 is minus 2. And here we get minus 3. Plus we have 4 minus 2 whole square, correct? Now, you could do this in one step also, but I'm just taking my time to show you each and every step. Minus 2 minus 3 is minus 5. You can multiply that with 2 to get minus 10. Is it clear? 4 minus 2 is 2 and square of 2 is 4. So we get minus 10 plus 4, which is minus 6. So we get this value as minus 6. Is that clear to you? Now, we need to find what is f of 1 minus n. So actually, we will write an expression here. We will not get a value, right? So we have to replace x with 1 minus n. So f of 1 minus n will be equals to 2 times 1 minus n minus 3, which is 2 minus 2n minus 3. Or you could write this as minus 2n and 2 minus 3 is minus 1, right? The last one here is 3g x minus 1 plus 2. So 3 times, let me use square brackets, g x minus 1. So replace x with x minus 1. So we get x minus 1 whole square minus 1, right? Plus 2. Now, open this bracket. So we get x squared minus 2x plus 1 minus 1 this one plus 2, right? And that gives you 3 times x squared minus 2x and plus 1 minus 1 is 0 plus 2. Now you can open this bracket and you can write this as 3x squared minus 6x plus 2. Is it clear? So that becomes your solution, right? Let's take the third question, which is if f of x is all this and g of x is this, find the value f of 2. Now what does that mean? F of 2, we are given these ordered pairs. So this is the input, that is the output. F of 2 is the x value, right? So this is the 2, f of 2 will be 3, right? So that is the value. So we can write this as f of 2 is equals to 3, correct? G of f of 4. So what you should do is look for 4 in the x coordinate plane. X value is 4, y value is 5. So I could write this as g of f of 4 is 5. So I'll write this as 5, right? Now we have to substitute 5 in our equation to get the value of g of x. So which is 2 times 5 minus 1, which is 10 minus 1, which is 9. Clear? C. F of g of 2 minus f of 3. So we write f of, calculate g of 2, substituting 2 in the second function. So we get, let me put a square bracket here. So we get 2 times 2 minus 1. Right? So that is g of 2. Minus f of 3 is 4. Clear? So we get f of 4 minus 1 is 3 minus 4. F of 3 is 4, right? F of 3 is 4. So we write this as 4 minus 4, so we get 0 as our answer. Part D is 3 times g x minus 1 plus 2. So we need to substitute as we did last time. So just substitute here. So we get this as equals to 3 times. So let's put square brackets. Instead of x, we'll write x minus 1, right? And then we'll write this minus 1 as such plus 2. So that gives you 3 times. So open this bracket. So we get 2x minus 2 minus 1 plus 2, which is 3 times 2x minus 3 plus 2, which is 6x minus 9 plus 2. Right? So 6x minus 9 plus 2 is 6x minus 7. So we get that as our answer, 6x minus 7. Okay, so that is how you could evaluate. So sometimes you get an expression, sometimes you get exact value. Here is question number 4. I'd like you to pause the video, answer this question, and then look into my suggestions. Number 4a. Find range of the function f of x equals to 4x minus 3, where x equals to minus 2, minus 1, 0, 1, and 2. So basically, you need to evaluate each value, right? So you could one by one, right, put minus 2 here and substitute the values to get 4 times minus 2 minus 3, which is minus 8 minus 3 equals to minus 11, correct? Now you can substitute minus 1. So f of minus 1 will be 4 times minus 1 minus 3, which is minus 4 minus 3, which is minus 7, correct? Then you can say f of 0. Substitute 0 here. We get 4 times 0 minus 3, which is minus 3. Similarly, let's do the other two values also, which is f of 1. So 4 times 1 minus 3, which is 4 minus 3, which is 1. And f of 2 is 4 times 2 minus 3, which is 8 minus 3, or 5. Correct? So we get those values. Now we want range of this, right? So what is the range? So from here, the y values, the f of x values are the range. These are the inputs, right? So these are the inputs or domain. So the range is, right, in curly brackets, all these values, right? Minus 11, minus 7, minus 3, 1, and 5. Is it clear? So that becomes the range. We have 5 elements in our range. Now, question number 4b is, represent the above function using mapping notation and then sketch the mapping diagram, right? Now, in mapping notation, this is the function notation, right? So we write mapping notation as f colon x, and we give this rule. The mapping is that each value of x, which is the input, has been mapped to 4 times x minus 3, right? So that becomes the mapping notation, right? So this is your mapping notation. So I hope you can see what a function notation is. So function of x, this is function, a function of x is 4x minus 3. Here, in the mapping notation, the function is such that x maps into, so here we are saying x maps, you can say, onto 4x minus 3. Is that clear to you? So that is how you could describe it. Now, second part is to sketch a mapping diagram, right? So whenever we are sketching a mapping diagram, we make the ovals or the circles to show the domain and the range. So that is one group which is being mapped to the other group. Now the first group is called the domain, right, or the input, and that is the range. Perfect. So in our case, minus 2 is mapped to minus 11, right? And then we have minus 1, which maps to minus 7. Then we have 0, which maps to minus 3. And we have 1, which maps to 1. And then we have 2, which maps to 5. And the mapping is shown with arrows, going from domain to range, correct? So this is 1-to-1 mapping. Each element in the domain is mapped to one element in the range, right? So this is 1-to-1 mapping, which you can see here. correct? So we can write the function f, which links the two as shown here, right? So that becomes your input. You can at times name them, right? You can say A is mapped to B, where A is a set of inputs. Normally, we write this as X and this as Y, right? So either way. So that is the mapping diagram. Perfect. Let's move on and take question number 5. Now this is a word problem, very interesting, and that's a thinking question for many test papers. Question 5 is, the average temperature of water at the surface of the Lake Ontario is 20 degrees Celsius during summer. This temperature decreases by 1.2 degrees Celsius for every 7 meter depth. Model the water temperature at any depth. Okay, so let's define a variable. So we can say, well, the temperature be T and depth be D, right? So in function notation, we can write temperature for given depth, right? So depth is going downwards. We're not using negative numbers, but we are using depth as going down, okay? So depth will be, maximum temperature is at the surface, which is 20. It is decreasing at a constant rate, right? This is a constant rate of 1.2, and it is 1.2 for every 7 meters depth, right? So for every 7 meters depth, not for every meter, right? For every 7 meters. So if the depth is 7, then it decreases by 1.2. Is that clear to you, right? So that becomes the equation, correct? So clearly in our equation, we have T is the temperature with depth. So we have T is function of depth in degrees Celsius, right? So T is temperature, right? And D is depth, right? So D is depth in meters, right? So we can define our variables like this, but that becomes your function, right? So model is given like this. Use this function to determine the water temperature at the depth of 35 meters. So the temperature at 35 meters will be equal to 20 minus 1.2. So we have 35 divided by 7, which is 5, right? So we write this as 20 minus 1.2 times 5, correct? So which is 20 minus 0 and 6 degrees we have to take away. So we get 14 degrees Celsius as the temperature. So we get this temperature at 35 meters depth is equal to 14 degrees Celsius. Is that clear? Part C is find the depth at which the temperature is 4 degrees Celsius. Write answer to 3 significant places. Now here we are given the temperature, so we'll write 4 degrees Celsius here. We need to calculate the depth equals to 20 minus 1.2 d over 7, correct? So that is your expression. So we can rearrange this. So we get 1.2 times d over 7 is equal to 20 minus 4, which is 16, correct? So we get d equals to, first we'll divide by 1.2, correct? And then we are going to multiply this by 7, correct? So we get our answer, right? So let's calculate. We can divide both by 4. 4 times 4, 4 times 0.3. So we get 28 over, we can write 280 over 3. Is that clear to you? We could do like this, 280 over 3. And now let's divide by 3. 3 times 9 is 27, 10. So we get 3.3 as our answer. And the units will be in meters, correct? So our answer here is 93.3 meters. So that becomes the depth of water at which the temperature will be expected as 4 degrees Celsius. Perfect. So I hope that makes sense. I'd like you to actually go through this calculation once again, understand how in a real life situation we should write in the function form, and it makes a lot of sense working with different temperatures and depths. Let's move on and take question number 6 now. Number 6. Now we have already crossed the mid mark. These are slightly difficult questions. I should say level 2 and level 3 questions. Question number 6 here is, lattice points are the coordinates pxy where both x and y coordinate values are integers. Write all possible lattice points on the graph of the function f of x equals to x plus 7 over x plus 3. Now many times in multiple choice questions we will have how many lattice points are there on this graph, right? So that becomes a multiple choice question. You may have to answer 4, 5, 6, 7, something like this, okay? Let's see how to figure out and how to solve this. So we are given the function f of x as equal to x plus 7 over x plus 3. We are actually interested in integer values, right? So it's a good thing we could write this as x plus 3 plus 4 over x plus 3, which you could think of as x plus 3 over x plus 3, right? Split this into two parts. One whole number, right? We are interested in whole numbers. You see that? So we get 1 as a whole number plus the other part, which is a rational function. Now it becomes simpler to identify what values of x can result into integer values of y. You get the idea, right? So that means x plus 3 should be a factor of 4 for f of x to be an integer. Now this is very, very important to understand. So do you get this part? So we are dividing 4 by something. So x plus 3 should be a factor of 4, right? Now if I say x plus 3 is a factor of 4, what could possibly be, right? So x plus 3 could be what? So we have to see the factors of 4, right? So we could have 1, we could have minus 1, we could have 2, we could have minus 2, we could have 4, or we could have minus 4. So these are 1, 2, 3, 4, 5, 6 values. Do you see that? So for these 6 values, we could have lattice points, which have both coordinates as integers, right? So now, for each, let us calculate f of x, right? So let's imagine that x plus 3 is this, right? Now if x plus 3 is that, let's make a table here. This is x plus 3, right? So in that case, what should be the value of x? So x will be equal to, this is x plus 3, right? So let me write like this. Let's say x plus 3, let's write this as a. So if that is a, then x should be equal to a minus 3. Is it okay? That is how it should be, right? And once we calculate this, we can calculate what f of x is. That is y, right? So, and f of x will be equal to what? A is x plus 3. So f of x will be 1 plus 4 over a. Is that clear to you? So that is how we are going to get the value. So let's calculate. So let's make this column first. We have to just take away 3 from these values. Taking away 3 gives you minus 2 here, minus 4, minus 1, minus 5, 1, and minus 7. So those are the x values. F of x values will be, we have to look into this value of a. So we are saying a is 1. So this is 4, right? So 1, when you divide into 4, you get 4. So this value will be 1 plus 4, right? So we get 1 plus 4 here, which is 5. You get the idea. Minus means 1 minus 4, correct? So you get a value which is minus 3. 2 means 1 plus 2, right? So it is 3, and when we say minus 2, so 1 minus 2, so that has to be minus 1. And for 4, it is 1, right? So 1 plus 1, which is 2, 1 minus 1, which is 0. Clear? So those are the values. So let's get the coordinate points. So let me write down the coordinate points here. So the coordinate points are the x and f of x values, correct? So x and f of x values. Those are the coordinate points. So what we get here is for x equals to minus 2, f of x will be 5. For x equals to minus 4, the value will be minus 3. For minus 1, we get 3. For minus 5, we get minus 1. For 1, we get 2. And for minus 7, we get a value equals to 0. Now, this is a very interesting and important question. I hope you understood the concept. Feel free to actually pause the video here, understand it completely, and then move forward. Let's take question number 7 now. Question number 7 and 8. I made a combination with the multiple choice questions, as you might see in some test papers, and we'll also explain the method of solving such questions here. Question number 7 is, given f of x equals to f of x plus 1 plus 2, if f of 3 is 5, then find the value of f of 5, right? How are we going to solve it? Well, we are given f of x equals to f of x plus 1 plus 2. Let's rearrange, right? So we get f of x plus 1 equals to what? It will be f of x take away 2, correct? So that is what f of x plus 1 will be. Now we are given f of 3. If I write 3 here, that is f of 3 plus 1 is equals to f of 3 minus 2. Now f of 3 plus 1 is basically f of 4, right? So f of 4 is, f of 3 is given to us as 5, 5 minus 2, which is 3, correct? So we get the value of f of 4. Now we can use the same method to find f of 5. So f of 5 should basically be equal to f of 4 minus 2. So that is 3 minus 2, and that is 1. And therefore, option A is the right option. Do you get this strategy, correct? So if the values are very close by, as we had, it was simpler to use this method and get the solution. However, if the question is something like this, given f of x is f of x plus 1 plus 2, if f of 3 is 5, then find the value of f of 100. Well, you cannot go on with this method. You need to have a formula here, correct? So we need to work out a formula. So how do we figure out what should be f of 100, right? So now we know it's a linear function. So basically we see it's a linear function, right? Where we already have two values. That is, at 3 we have the value 5, correct? And also we found that at 5 it is equal to 1, right? So that ways you can actually find a new function f of n using these two values, right? You could write f of n, let's do y equals to mx plus b, for example. Do you see that? So here, what is the slope? So let's do this work, and then we'll write the function. So I'm doing the work here now. So m basically is change, which is 5 minus 4, 5 minus 1 over 3 minus 5, which you know in this case was minus 2, right? That is what you're subtracting with. So we get 4 divided by minus 2, which is minus 2 as expected, correct? So if I substitute minus 2 here, then what should be b? That is what we're trying to figure out. So we say y equals to minus 2x plus b. You can use any one of these points. 3, 5 was given to us. So 5 equals to minus 2 times 3 plus b. Bringing it to this side, so we get 5 plus 6 equals to b, which is 11. So we can write f of n is basically equal to minus 2n plus 11. Does it make sense to you? Correct? So that is the formula which you need to derive, which is not very difficult since you have seen that you're going down by minus 2. So multiply by 2 and then figure out the y-intercept value, kind of, right? At 0 what it was, correct? Okay. Now we know f of 100 is what? Substitute 100 here, right? Plus 11, so minus 200 plus 11. Is that okay? So that is how we are going to get the value. So if I take away 10, it is 190. So it is minus 189, right? So that is what we are going to get the answer, minus 189. So that becomes the answer. Is that clear to you? So I hope it makes sense. It is a very important question, once again, seen in many test papers, right? Here is second last question, question 9. Let f of x be equal to x squared minus 2x minus 3 and g of x equals to 1 over f of x. At how many points will the two functions have the same value? That is, g of x equals to f of x, right? You can always pause the video, answer the question, and then look into my suggestions, correct? Now, physically, what you could do is, algebraically, what you could do is you could equate the two equations, which is you can do x squared minus 2x minus 3 equal to 1 over x squared minus 2x minus 3, cross multiply and solve, right? But that is for a multiple choice question, I will say a wrong method. So avoid, don't do this, right? Because that is going to take too much of time and it's not good enough for a multiple choice question. So what should you do? So here's the strategy. So we are saying that f of x equals to, I could have written either way, right? 1 over g of x, correct? So in this case, it is very clear that f of x should be equal to plus minus 1. Only then that is true. Is that clear to you? So the strategy here is to solve for f of x equals to plus minus 1, correct? So that is one strategy. Now, the idea here is we are actually not interested in point, right? So this is another important thing. Since we are not interested in actual points, no need to solve. Perfect. So finally, the strategy is what? So what should be a good strategy? You could actually figure out how many points. The question keyword is how many points. So how many points will f of x be plus minus 1? That is what we need to figure out, right? So think like this. This is at 0 minus 3, right? So a point definitely at 0, it is minus 3. And it opens up. So we have a parabola. Opens up, right? And we have already identified that there is a point somewhere minus 3, right? We are not even working out the vertex, which will be at half of this value. Perfect. Half of this value is minus 1. So somewhere there will be a vertex. But what we do know or understand is that this parabola will be something like this. And what we are interested in, plus and minus 1. There are 4 values, right? So where we have y value as plus 1 or minus 1. So these are the 4 points. So the answer is 4. So since the parabola will have plus minus 1 at 4 points, option 4. D is correct. Does it make sense to you? So as soon as you see the question, you could think like this, and within a minute you get your answer. You get the approach, right? So that is your best strategy. So let me highlight this, best strategy. Perfect. So that is what you have to do in a multiple choice question if you get a question in this form. If you need to find the points, then the best way was to figure out and solve for this equation for f of x equals to plus minus 1. Is that clear to you? Perfect. Let's move on and take the next question now, which is also the last question. Question number 10. Refer to the function in the table below to evaluate each of the following values. I will actually like you to pause the video now, answer this one, and then you'll be sure that you understand everything. which we have discussed in this particular video. Let's answer. So we are given x values, the inputs, f of x, one function, g of x, another function. We need to find out what is f of g of 3. So when we say g of 3, inside function first. So start with inside out. So we are calculating g of 3. That means at 3, what is the value of g, right? So at 3, the value of g is what? That's what we are trying to see. So at 3, the value of g is 4. So we write here f of g of 3 is 4. Do you see that? So we calculated inside function g of 3. Now we want to find the value of the function at x equals to 4. So we are looking into this circle now, right? So at 4, we get the value as -1. So that becomes our answer. Is that clear to you? Let's look into the second one. We'll do the inside function. 2 times g of f of -1 whole square. So f of -1 whole square, okay? So f of -1 is here. So we get this as equal to 2 times g of, now this whole square, right? So 2, right? So we get 2 square. Do you get the idea, right? So we are looking for 2 square is 4. So now we are looking into this part. So at 4, the value is 1. Perfect. So what we get here is 2 times 1, right? This value 1 will come. And then you multiply this by 1, 2 and 1, you get 2 as your answer. So this value is 2 and this value is -1. So I hope this is absolutely clear. So in this particular exercise, you must have seen that we adopted different things, tables, formulas, kind of graphs, mapping diagrams, and we evaluated functions for different values. I hope that makes sense. Feel free to write your comments, share your views, and if you like, subscribe to my videos. That'd be great. Thanks for watching. And I thought, before going, let me give you 2 questions here. So I'd like you to answer these 2 questions. So if I write f of g of -1, now the options for you is, okay, think about it. Do we have a value here? So what you figure out is, let's discuss this. So g of -1 is -5, correct? So we get f of -5, but we don't have -5 here, right? So that does not exist. So sometimes in functions, you may land up in situations where there may not be a value. Perfect. So that is kind of very important. So we'll also see into domain and range part of the functions, which will be our next unit, and also the mapping diagrams and transformations, which we'll discuss later. And then you will also figure out that so many times we may not have a value of function for some inputs, since those inputs are not in the domain of the function. You get the idea, right? So let me close it here. I hope that helps. Feel free to write your comment, share your views, and if you like, subscribe to my videos. That'd be great. Thanks for watching and all the best.